NASA says its Explorer 1 test, the most far-off human-made object in the universe, is sending usable data to Earth again following quite a while of rambling jabber. NASA's Explorer 1 and 2 of humankind's most aggressive space missions have quite recently sent back information that could change all that we know about the universe. What they've found at the actual edge of our nearby planet group is sending shock waves through the academic community, with implications that go a long way beyond the limits of space exploration. The most surprising discovery is a completely new magnetic field, one that was rarely anticipated and one that could drive us to re-examine our understanding of the whole interstellar climate. Imagine this. The sun's magnetic influence was believed to fade as the rocket crossed into interstellar space. However, Explorer has experienced a magnetic force stronger and more complex than anyone guessed. This startling find isn't simply a scientific curiosity. It could have significant ramifications for the way we understand space travel, the security of our planet from cosmic radiation, and indeed, even the very nature of the universe. While NASA scrambles to interpret this revelation, the ramifications for humankind are broad. If the interstellar magnetic field is as vast as Explorer's data suggests, it could open up new avenues of exploration and even step-by-step processes for surviving space colonization. However, if it's part of something more hazardous, something yet unknown, we could be facing an unanticipated danger. This discovery comes at a pivotal moment as SpaceX and other private space ventures are on the verge of establishing a human presence in deep space. What does this new data mean for our security, our technology, and our future? For decades, the Explorer missions have been humankind's eyes on the farthest reaches of space. Yet, what they've revealed at the limit of the solar system has upended all that we assumed we knew. Explorer 1, now more than 23 billion kilometers away from Earth, past the heliopause where the sun's influence ends, entered the vast expanse of interstellar space back in 2012. However, what it found was not the quiet, empty void expected by researchers. Rather, it encountered a dynamic environment filled with startling anomalies that could change the future of space exploration forever. The most stunning discovery came in the form of cosmic rays, high-energy particles that are normally associated with violent events occurring in supernovae and black holes. Researchers had long believed that the solar system acted as a protective shield, diverting much of the cosmic radiation that permeates space. Yet, Explorer's instruments detected a disturbing increase in cosmic ray intensity as it crossed the heliopause, suggesting that this protective barrier wasn't functioning as expected. It wasn't just a minor anomaly. It was a significant spike, one that researchers were unprepared for. This unforeseen change in cosmic ray levels raises troubling questions. Are we truly prepared to cope with the harsh conditions of space beyond the protection of our sun? Could these unexpected radiation levels pose a threat to future interstellar missions, especially to the astronauts who will venture far beyond Earth's orbit? What else is out there in the interstellar medium that we haven't even considered? These cosmic rays could be a symptom of a much larger, more subtle force lurking in deep space. If that's the case, it's something humankind is woefully unprepared for. NASA and other space agencies are urgently investigating these measurements, but with private space initiatives like SpaceX pushing toward Mars and beyond, this is no longer just a theoretical concern. With each passing year, we draw closer to sending humans into space for extended periods. But this new information points to dangers no one had anticipated. Forces in the deep unknown that may pose far more threat than anyone realized. NASA's role in exploring the outer reaches of the solar system is no longer a matter of curiosity. It's a matter of survival. The rare data Explorer has sent back about the behavior of the heliopause, the boundary between the sun's protective bubble and interstellar space, is shaking up everything we thought we knew about space dynamics. However, as this discovery expands, so does the need for a more advanced strategic response. For decades, scientists believed the heliopause, where the solar wind from the sun meets the interstellar medium, would be a smooth and well-understood boundary. However, Explorer's findings have revealed something much more complex. Instead of the expected steady decline in solar wind, Explorer has uncovered unusual magnetic and plasma variations that defy current models. These surprising shifts suggest forces we can't yet explain. Forces that could have significant implications not only for space exploration but for Earth's security as well. NASA, with its vast network of specialized technology, is now tasked with unraveling these mysteries. The agency's unique position, its immense experience, specialized data-gathering capabilities, and advanced modeling systems makes it the only entity equipped to lead this investigation. From the ultra-sensitive instruments aboard the Explorer spacecraft to the supercomputing power used to process data in real time, NASA is the only organization with the resources to turn these surprising discoveries into actionable knowledge. But it's not just the data collection that sets NASA apart. It's their approach to interpreting the very nature of the forces at play. Their mission is far from over, with a series of follow-up moves planned to track the changes in the interstellar medium and gather more detailed readings of the magnetic fluctuations. Using their expertise in space physics, NASA plans to model the interactions between the heliosphere and the interstellar environment, creating models that could predict the potential dangers of this new behavior. They're already preparing for a series of groundbreaking missions to launch in the coming years to probe deeper into interstellar space. Explorer has just begun to explore, but even with NASA's capabilities, these unfamiliar magnetic forces present a major challenge. If these forces are as powerful and unpredictable as they appear, they could affect future space missions, potentially endangering the safety of astronauts venturing beyond Earth's protective bubble. And what if these variations in the heliosphere are just a symptom of something much larger, something that could affect the entire solar system? Later discoveries at the outer reaches of the planetary system are forcing scientists to confront a chilling reality. We may not fully understand the forces at play in space. The spacecraft's instruments have detected anomalies in the space between stars, anomalies that can't be explained by current scientific models. These startling interactions between solar wind, cosmic dust, and the interstellar medium suggest the presence of unknown forces that could have profound implications for the future of humankind. The discoveries are especially unsettling because they suggest that what we thought we knew about space, our solar system's protective bubble, and the behavior of cosmic components is far from complete. Explorer's instruments have picked up inconsistencies that point to a complex, previously unknown interaction between solar wind and cosmic dust particles, disrupting the smooth flow. Radiation exposure could lead to devastating health effects, jeopardizing long-term human space missions. These missions, critical to SpaceX's and NASA's plans, may be significantly delayed or even abandoned if researchers can't find ways to mitigate this radiation. But the risks don't stop with space exploration. The rise in cosmic rays could also affect terrestrial technologies. Satellite systems, GPS networks, and communications could all be impacted by heightened radiation, leading to disruptions in everything from global communications to military operations. The increased radiation could damage infrastructure and even threaten the safety of everyday life on Earth. Imagine a world where the technology we rely on for everything from navigation to weather forecasting suddenly becomes unreliable, all because of this invisible force from deep space. This situation also raises enormous ethical questions as we push the boundaries of space exploration. Should we be considering the safety of those who will be the first to venture into this perilous territory? Should space agencies be held accountable for the risks posed to astronauts? Moreover, the prospect of space colonization, something many have long dreamed of, now takes on a darker tone. What does it mean to send people into a hazardous and poorly understood radiation environment? What moral responsibilities do we have to those who will follow in the footsteps of Explorer and explore beyond our solar system? But there's more at stake. If the heliosphere is weakening, it's possible we're witnessing the beginning of a larger cosmic event, something that could affect space travel as well as life on Earth. Could these rising radiation levels be part of a broader, impending cosmic event that we're only beginning to understand? Could this be the catalyst for a new era of space dangers, one we're not yet prepared for? The Explorer missions, long past the hill, continue to make waves, particularly in the field of communication. This unprecedented achievement in data transmission, especially given the spacecraft's age and the challenges posed by the interstellar medium, has caused a stir among space scientists and engineers alike. The question is, how is this even possible, and what does this surprising accomplishment mean for the future of space exploration? Scientists in the field of space communication initially expected that as Explorer's distance from Earth increased, the data transmission rate would decrease significantly due to the fading strength of the spacecraft's signal. However, recent data shows that Explorer 1 is still sending back crucial information at a rate far higher than expected. The spacecraft is still operating at a modest 160 bits per second, compared to the initial rate of 15,000 bits per second, but at such extreme distances, this rate is still remarkable. An achievement like this pushes the limits of what we thought was possible in deep space communication. One of the key reasons this is happening is due to the spacecraft's communication technology, which was designed to endure and transmit for incredibly long periods. Explorer's high-gain antenna is still working, sending messages to Earth with remarkable clarity. This longevity is attributed to NASA's meticulous planning and an ongoing mission to improve the spacecraft's ability to process and compress data for efficient transmission. As a result, even with a nearly 22-hour round-trip time for data signals, Explorer's high-speed performance is allowing for the continued discovery of important information about the outer reaches of our solar system. However, this surprising communication achievement has led to some interesting predictions and potential outcomes. According to Dr. Edward Stone, former Explorer project scientist at Caltech, the continued success of the Explorer missions in terms of data transmission is one of the most significant achievements in space exploration. We are now learning more about deep space with each passing day. What makes this even more remarkable is that such performance could serve as a model for future space missions that venture into even deeper, more distant areas. If Explorer can continue to transmit for years to come, it could drastically change the way we design long-term space exploration missions. On the other hand, there are potential drawbacks to this continued data transmission. For one, the reliance on the spacecraft's communication system for critical data may eventually become a liability as the spacecraft's power reserves continue to deplete. The power supply is expected to run out by around 2025, and the ability to send data back to Earth could be severely hindered. The spacecraft is already operating with limited power, using the remainder of its nuclear power source to keep its instruments active. Should the system fail, there could be a significant gap in the data collection process, leaving researchers without essential information at a crucial time. Explorer's journey into unknown space has already exceeded every expectation, uncovering the unfamiliar areas of the interstellar medium with remarkable detail. But as the spacecraft pushes further into the void, it uncovers more questions than answers, a troubling reality for scientists who thought they understood the edge of our solar system. What exactly is out there in the vast space between the stars? While Explorer continues to send back valuable data, it's still unclear what it's encountering, because what it's finding challenges everything we knew about interstellar space. The space beyond the solar system is nowhere near the quiet, empty void expected by researchers. In fact, Explorer's instruments have detected fluctuating magnetic fields, strange radiation patterns, and anomalies that suggest the presence of previously unknown forces and bodies. These surprising communications with objects that weren't even expected to exist have left scientists scrambling to find explanations. One of the most intriguing possibilities is that Explorer has encountered unidentified interstellar objects or even an entirely new type of cosmic body, something that our current instruments and models have never been able to detect. This could be the discovery of something entirely new, possibly a form of matter or energy not yet observed. If these discoveries are accurate, they could change our understanding of the very fabric of the universe, and with it, the potential dangers and benefits to humankind's future in space. The key question now is, how do we prepare for what's out there? Could these unknown bodies pose a threat to future space missions? Or might they one day hold the key to unlocking the mysteries of the cosmos?